Hello everyone, welcome to another video. In today's video, we're trying to exploit another machine on HackTheBox. The name of the machine is Perfection. It's a Linux machine and the difficulty rating is easy. So we have the IP address. So the machine is live. And then for this machine, after our initial scan, we realize we have two ports open. Port 22, which is SSH, and then port 80, HTTP. So on the HTTP ports, a website is running. So this website is used by students to calculate their weighted averages. And then we realized that this particular website is vulnerable to server-side template injection. So with this, we try out some SSTI payloads. And then we also realized that the backend server is based on Ruby programming language. So we try to use Ruby SSTI payloads, and we also realize these payloads there's some filtering going on. So we try different characters and different ways to escape or bypass the filtering, and then we have success using the new line, that is \n. So if you use the new line character, we are able to bypass the filtering, and then this gives us the opportunity to execute command on the server. So this is how we get our foothold. And then for the privilege escalation, kind of interesting. So we realize that we are able to get a foothold into the server as the user Susan. So we're checking the sudo user of Susan. We realize that Susan is part of the sudo group, but to be able to see what application the sudo user Susan can run, we will need to authenticate or need username and password. But we just have the username Susan, we don't have the password. So that's the furthest we can go. So we have to find a way to look for Susan's password. So further enumerating the system, we realize that Susan has a mail folder with an email correspondence with another colleague, and then reading through the email or the mail, realize there's some migration going on. They are trying to migrate from their old system to a new system because of a recent data breach. And then in the conversation, we realize that they want to implement a new password policy. So this is very important because we'll use this password policy in Hashcat to crack whatever hash we are able to get our hands on. All right, so the next thing is that in Susan home folder we see an SQLite database. So in this database we see password hashes, and then luckily we have a hash for Susan. So we have a hash, and then we have an idea of how the password is going to look like based on the password policy that was discussed in the email. And then we are able to craft a hashcat mask command, and then with that we are able to get the password for Susan. So we use Susan password, and then we use sudo, and then we are able to see that the user Susan can run all commands, every command on the system. So we just use sudo su, and then that gives us root. So with that much I say, let's hop into the machine and see how we can achieve that. So let's copy the IP address. We click on this, see the IP address gets copied to the clipboard. And then what I would do is I would like to add the IP address to let's see if this works. So perfection.htb. Okay, so what we need to do is we need to see if it works this way. All right, so let's, this is our IP. We added our IP to our host file, so now we can refer to it as specification. All right, let's close this. And yeah. All right. So let's see if we can ping perfection. Yeah, we can ping perfection. So we have access to the machine. Then we just do our nmap scan. Sudo nmap dash tag scv tag on. So we want to save the output as nmap. And then I should you to see the both output. So let's use a main rate of let's say 10,000. And then what else? I think that should be it. And then we just say perfection dot atb. So let's see. Okay, what scv. Okay, so in my command we have an issue here. So this is supposed to be small s, not capital S. All right. So we see that we have two ports open, port 80 and then port 22. So yeah, port 22 is SSH. We don't really have much. When we see open SSH, it's running on Ubuntu. And then we see the web server or HTTP ports, and then it's running Nginx. And then these are the supported methods. This is the title of the web page or the website. And then we have weighted grade calculator. So let's go to, let's visit the site. So http, let's say perfection.htb. Let's see how it looks like. So this is how the site looks like. And then interestingly, when we come down, we can see that it's powered by WebRig 1.7.0. So obviously what we do first is to check this particular version. So what is WebRig? It's a Ruby based web server. So WebRig, let's see what WebRig is. WebRig is an HTTP server toolkit that is configured as an, so it's like a server based off on Ruby. We can do a full read. Nothing much here. I just want to find some information about WebRig and what it WebRig. Okay, so you see that it's a Ruby server toolkit, so it gives an idea what WebRig is. So if you want to host your own server, you can come and download the releases, and then you can run your own server, just like we have Apache and then Python HTTP servers. So WebRig also gives us that kind of capability. All right. So and then checking to see whether this particular version of WebRig is vulnerable, like this, like you don't see any vulnerability. The vulnerability that were posted are very old vulnerabilities not related to this particular version of WebRig, so that is not the way to go. And then how we come and look at about us, you see about the team. So we have Tina and then Susan. So Susan is a professor of computer science, and then Tina is a web developer. So the site is developed by Tina, and then when you go further and read, she was the one who came up with the entire idea. And then she is an absolute whiz at web development, but she hasn't developed into secure coding too much. So this is something that is trying to tell you that there may be something vulnerable with this side because it's not too detailed about secure coding. So probably there are some misconfiguration or some miscoding, or just to let you know that something might be wrong with this side. All right. So let me go to the next tab, which is weighted grade calculator. So we can calculate our grades here. So enter a maximum of 5 category names. So these are category names. We say A here, B here, C here, D, E, and then the grade. I'll just put 10, like 10, 10, 10, 10. We're just trying out the sides, and then the weight. So the weight should cumulatively be 100. So if we say 20, so you have to all add up to 100. So 2020, 2020, and then 20. So let's submit this and see. So this is the total grade. Your total grade is 10%. So it has calculated our weighted average for us. And then, yeah, so that's it. And what do? We try to, if you try to put any characters that's potentially going to execute code, let's say maybe we're just trying out we're gonna add SSX payload, and then if we try here W something, we're just putting some, and then and here as well put 20 20 20 20 20. All right, so malicious input blocked. So it's telling us that we are trying to input something malicious in the category field. So this is kind of like telling us that there's some filtering going on. Check for special characters and then some malicious input characters. All right, so what we do is we try to intercept this request. Let's use suit. Try to intercept and then manipulate the or modify the request before we send it to the server. And let's see. Okay, so we have suit open. So let's see, we are not intercepting yet. Let's okay. So what I will do is I will just say a no a B C D E. Okay, so those are our categories, and then I'll just put two, and then also our weights. I'll make sure that they sum up to 100. So now instead of submitting, we going to turn on our web proxy. It's on now, and then we need to intercept. So let's put interception on, and then we submit. So we have our web. Web has received our request. So what we do, let's send this to repeater so that we can have access to it to manipulate it. We can turn off the interception and then go to repeater. We can send this command and we're gonna have the same output. So there's a form like let's see, yeah. So our results come after this particular part of the form. So we can say we want to search for form. All right. So if anytime we change something here, so, oh, this is category 1 is equal to A. So if we change it to B or BC, is supposed to change. So you see that we have BC here. We can change it to test. Let's see, it changes to test. So if we add some character here, and then we have malicious input blocked. All right, so there's some character filtering going on here. So after trying to bypass this severally, realize that if you put the \n character, you should be able to follow it up with any other character. It's not going to. So after the \n, you can put any other thing to still work. We'll see that it's still blocked because the \n is not able to interpret. We have to encode this \n character. We have to URL encode it. So the URL encoding of the \n is %0a. So if you do %0a, you should be able to see test and then DSA. Let's see if that is going to be true. Yeah, so you see that we have test and DSA. So it's like we are being able to bypass that particular filtering, and then we have to now look at the way we can inject templates into this particular website. So that is the SSTI. So we can look for, let's say, Ruby. So Ruby template injection is like the format is it looks like, let's see. Okay, let's take some note. Perfection. All right, so for Ruby, a template is like this, and then that is the template. So whatever you put here is going to be injected, or it's going to be dynamic. All right, so if we put, let's try to put 2 times 5. So 2 times 5 is supposed to give us 10. All right, so if this works, it's supposed to give us 10. Let's try. So we can try to, we have to URL encode this. All right, let's see. Okay, it's blocking it and telling us it's malicious input. So probably our URL encoding is not done well. That's what I suspect. Let's use decoder instead to do the URL encoding. So we are URL encoding this, that, and then 2 times 5, we expect to see an output of 10. Alright, so let's encode this with URL. So let's use this URL encoded. Let's go back to repeater, and then this is %0a, that is the \n, and then we'll add a URL encoded payload, and let's see what we get. It's still telling us the malicious. Okay, let's see. There have to be something wrong somewhere. Let's get this off. Still malicious blocked. Test. Still malicious blocked. So it's like there's something wrong. Alright. This is not correct. If we don't even put anything, it's still telling us malicious block. So I think there's an issue with this particular request. So let's just grab another request. So a just feel lazy, I don't want to type. Alright, so we can put 20. Alright, and then let's grab, what is it? Let's intercept another request. Alright, so we send this to repeater, and then let's see another one. So we have 3. So if this stop working, we'll come back to this. All right, so we have it here, and then we're trying to add our \n encoded character, which is percentage 0a, and then now our let's stop this, and then now we add our payload, which is a template. So in the template we have 2 times 2, so we're expecting to see 10 after the a character. Let's see if it works. All right, so let's search for form. All right, so you can see that we have 10 here, so like the code has been executed. All right, so we have code execution, and then now we have to try to, so this is just a simple calculation that we did. We have to try to see if we can run a system command. All right, so um, so to run system commands, instead of just putting this, we can put something in the so I think when we have percentage x, and then whatever is here should be able to run. So we can find out um, running system commands in Ruby. What happened? Mm, preventing Firefox is supposed to run without a problem. Okay, let's disable proxy. Alright, so various ways to run system commands in Ruby. We have it here. Yeah, so all these ways are going to run, but the one that worked for me was if you do percentage x, whatever you put here it can run. So let's say who am I? I'm trying to run who am I. So before, so let's put back our web proxy. Let's run this again and see if it works. It's still working. So we encode this. So this is the encoder, and then who am I? We expected to see the name of the user. So let's go back to our repeater. So from here we can delete all this. So this is our \n character, and then we can just add our payload, and then we should be able to see some results here. All right, so who am I? So this is the user, so the user is Susan. All right, so it's like we have command execution. So what we do now is to be able to grab a reverse shell. So let's go back here. We can go into a new window, and then let's divide the window, and then we'll just nc lvmp. So let's grab it on 777. All right, so this is where we are listening on. We're expecting our reverse shell here, and then let's try to craft a payload. All right, so we do bash -c, and then bash tag I goes to this, and then def tcp, and then 10.10.14. Let's see what our IP address of our tunnel is. Turn 0, so it's 40. All right, so we come back here, .40, and then we are listening on port 777, sorry, 777. All right, and then we go to 0 and 1. So this is the payload. So this payload should be able to work. So if this payload runs, so it's sort of who am I trying to substitute in this payload. All right, so this should be our reverse shell, and let's see. But before we run that payload, we need to decode the payload, sorry, encode it. So let's go to our web decoder. So this is the payload, and then now let's go back to repeater. We have repeater here, so we delete from this side to that side. Let's delete it and then put in our reverse shell payload. If everything goes right, we are supposed to be able to see a reverse shell pop up here. All right, so let's see. All right, so it's taking some time, so this is a good signal that something good is happening, and voila, we have a reverse shell. All right, so we can come here and then we'll say who am I. So we are Susan, so that's the user Susan. And then what do? Let's try to get a proper shell. So let's see what is the Python, which Python. Let's see, let's make sure that we have Python. Yeah, we have Python 3. So we say Python 3 -c, and then we import pty.spawn, and then we do bin bash. All right, okay, so this has given us a proper shell, and then we do control Z, and then we do STTY raw -echo FG. All right, and then we want to be able to clear, so export term equals to xterm. So this we can now be able to clear our screen. So yeah, we have a proper shell now. So we do sudo tag, we do id. So if we do id, realize that Susan, the user Susan, belongs to the sudo group, but we don't have Susan's id, sorry, Susan's password, so we cannot do sudo tag l because it will request for a password. So it's asking for Susan's password, which we don't have. All right, yeah, so we don't have Susan's password. So what we can do is we can try to find specific files for Susan. So find, and then group Susan, and then let's say type this file, and we redirect every errors to dev null. All right, we're trying to find interesting files that Susan can access. Okay, so this is a lot of input. So let's get rid of some of the input. So let's get rid of some of the input. So what I will do is I'm going to get rid of proc and then home. It's like in proc and home, we don't have anything interesting there. So let's clear and then run our command, and now we'll pipe the output to, let's do egrep, and then dash v, you want to remove output that contains proc or home. Okay, let's see what we'll get next. Yeah, so we see that we have this file. We can do ls.l, see if it's a file or folder. Yeah, so this is a file. So we have this particular file. If you go to var mail, so Susan has a mail, so we can check what is inside this particular mail. So let's do cat. Let's cut this, and then we can see some conversation going on. We can copy this out. So dear student, transition, due to our transition to Jupyter grades because of pupil part data breach. So there was a data breach. They were originally using pupil part data, pupil part, and then the credentials. All right. So to make things easier for everyone, the password format. So this is the password format they want to use now. So the first name backward. So like you reverse the first name, and then randomly generates an integer between 1 to 1 billion. Okay. So this is a password policy that they want to use. So password policy. So this is a password policy. All right, and then please hit me with updates on the migration. So it's like they are trying to do some migration as well, so they will migrate from one platform to another platform, and then they want to change the password policy so that it becomes very difficult for their passwords to be cracked or something. Yeah, so that's fine, we have this information. So what do we do next? Let's go to Susan. Let's try and let's do cd to take us to the Susan's home folder. Let's clear, and then when we list, we see this is a folder, a migration folder. We cd into migration. All right, and then if we ls minus le, so we see pupil part credential. So this is the file. I don't know what kind of file it is, but we can check with the file command. It's like a database. So this is an SQLite tray database. Last written using, so this is an SQLite database. That's what we know. So we can try to open this SQLite database. We'll try to see if we have SQLite installed in the first place. If not, we have to exfiltrate it to our machine. But let's see whether the server has SQLite tray. So yeah, we can see that SQLite tray is installed. It's in the user bin folder. All right, so that's fine. So we can just use it. We can say SQLite tray, and then we'll use SQLite tray to open this particular database file. All right. Okay, so we've opened the file with SQLite tray, and then you have to use SQLite tray command. So if we do dot table, let's see. Is it table or tables? Let's do table. Okay, I think I'm trying to see the tables that we have on this database. Okay, Okay, so over there, I think they're asking us to be able to get help. Okay, list names of tables matching. Let's see. I just want to find tables. So, databases. Okay, so this is the database. I think it's the table. Yeah. So I don't know why we got it. We didn't get. So yeah. So if you do the table, you should be able to see the table. So we have only one table here, which is users. So we can use select command. So select everything from users, and then yeah, we have the information in the users table. So we can copy this out. So let's do that. We copy this out. All right, so this is Susan Miller, and then this is Susan's hash. Okay, so what we do is we are trying to crack this particular hash using this password policy. So we can use Hashcat, but we already know part of the password, how it's going to look like. It's going to be first name. So the password is going to be like Susan underscore and then first name backward. So we can check if you want to find how to reverse the string. We can use Python to do that. Let's see. So we can print out Susan, and then we trying to reverse Susan. Yeah, so if you want to reverse Susan, you're gonna get Nasus. Yeah, so that's how it's gonna look like. So it's gonna be Susan Nasus underscore. So we've gotten this part of the password. So now the next part is the randomly generated integer between 1 and 1 million. So that's gonna be between, it's gonna be 9 digits because it's going to be between. All right, so we can use a hashcat mask. All right, so let's try to generate a hashcat command or payload to crack this. So say hashcat and then the mode. So we have to know so M is the hash type. So the hash type where we can check, we can use hash identifier. So let's see hash. Okay, I have hash ID. Okay, I think I don't have hash identifier. I'm just gonna install it quickly. So I'm gonna pause the video and install hash identifier and come back. Okay, so apparently hash identifier was already installed. I don't know why it didn't run. So I'll just say hash. Okay, so there was supposed to be something like this, hash identifier. Okay, and then we put our hash in to see what hash we've got. So our hash is possibly SHA-256. So this is SHA-256. All right. So you know we have an idea of what our hash is. So let's go back up here. Let's close this. And then with Hashcat, let's see the mode. So let's say I want to see the mode of SHA-20, the hash type. So let's let's say hashcat example hashes. All right. Okay. So so what I'll do is, instead of example hashes, I'll just do hashcat uh, help. All right. So, and then we can pipe this to less, and we should be able to find SHA-2. Let's see. Yeah, so this is SHA-2. So we want the raw SHA-2. So this is SHA-2 256. All right. So the hash mode is, the hash type is the mode is 1400. So we can come and put it here. What is it? So the mode is 1400, and then the attack type, we're gonna use attack type 6, which is gonna be a hybrid word list and then mask. So if we come back to, if we look at our attack mode, so when you see 6, that is hybrid word list and then mask. So that's what we're gonna use. And then so our attack mode is gonna be 6, and then we're going to put our hash in a file. So let's do that. So we can exit out of Hashcat. Okay, so let's just echo our hash to a file called hash. All right, let's cut hash and see if we have, yeah, so we have hash. And then our word list, we are trying to crack only the password for Susan, so that's what we're gonna put in the word list. But that's going to be part of the password which we have already formulated. So we're gonna do, let's put this, we're gonna echo this into a file called wordlist.txt. All right, yeah, so if we list, so we have word list and then we have hash. We can even change the hash to hash.txt. So we have the hash file and then we have the word list. So now we can use our Hashcat. Okay, let me do the Hashcat in a new window. I can name this window Hashcat so that we know that this is where we're doing our cracking. All right. So our hash file is going to be hash.txt, and then our word list is wordlist.txt, and then our mask is going to be nine characters, because one billion, so one between 1 and 1 billion is going to be 9 digits. All right, so we do 1 2 3 4 5 6 7 8 9. It's a 9. So let's see if this is 9. So this should be able to give us 18 if actually it's 9. So let's do echo, and then we pipe this to word can't see. So this should go, if this is 18, then we have, okay, so why is it 19? It's supposed to be 18. Okay, yeah, so that's correct. All right, so that's fine. So this should be our hashcat command, if everything goes well, they should be able to crack our password. So let's see. Okay, so match is not found, so I think we need to escape the question marks. That's what I think. Let's try. Okay. Yeah, so Hashcut has started. So this is gonna take a bit of some time, so I'll pause the video and then come back when the cracking is done. Alright, so the cracking is done. It took about 2 minutes, 20 seconds to crack. So this is the hash and then this is the password. Alright, so we have the password as Susan4. So I'm just gonna copy the password and then we go back here. So on top here, okay, let's see. Let's say we can say create. So the user is Susan. And the password, we have the password here. So now that we have the password, we can go back. Which window are we? To. All right. So let's come back here. So let's exit from SQLite. How do you exit? Okay, I think it's supposed to be okay. So we've been able to exit from SQLite, and then now we have sudo tag l, and then it's prompting for a password. So what we need to do is just to put in our password that we cracked for Susan. Okay, so we can see that Susan can run the following command. He can run every command on the machine perfection or the server. All right, so what we need to do to get root is just do sudo su, and this should give us root. So we are now root. If we do who am I, we are root, and then the machine has been rooted. So we can now go and look for our files. Let's say find and then name. Okay, let's do full screen. Name user.txt, and then the type is file, and then we list and we pipe errors to dev. Now we are just trying to locate the user flag. So this is the user flag, and then when we cut the user flag, so we have it. So let's go and then we say flags. So we have the user flag and now the root flag. So let's look for the root flag. So instead of user.txt, let's look for root.txt. So the root flag is also located somewhere here. So we do cut. Okay. So that's it. We have our root flag as well. So let's go and then put this in our. We submit this flags. So come on, how do we submit? What's happening? Okay, so I think we need to disable our proxy and then come back. All right, so difficulty easy. Okay, so root flag. Yeah, so the machine. Right. Watch then. Like the video, like and then subscribe, and then see you again in another video. Thank you so much.